Welcome, folks. I am Jabby Kaway, joined by Steph's Bra. What up, brah?
What up?
We're looking at Physicist breaks down the science of 10 iconic Marvel scenes. How real is it? From Insider. You guys, thanks so much for joining us. If this is your first time hanging with us, hit that subscribe button, bell icon, all notifications, and pretty please vote this up. Let YouTube know you're enjoying what you're watching, and check out Steph's Bra on the social media, Instagram, and the World Girls on YouTube.
You've been taking bullets, charging it up with kinetic energy.
He turned off the artificial gravity everywhere but in here.
It's quantum entanglement between the quantum states of Posner molecules in your brains.
Do you guys just put the word quantum in front of everything?
I gotta say, we do put the word quantum in front of everything. Hi, I'm Jim Kekelius. I'm a physics professor at the University of Minnesota and the author of The Physics of Superheroes.
Oh, wow.
Oh, cool.
That's cool. That's dope. And had him write the physics behind them.
That's a scene from the first Guardians of the Galaxy movie, and as they're making their jailbreak, Rocket turns off the artificial gravity in the space station so that everyone else floats and is unable to get their bearings, and they make their escape.
I told you I had a plan.
Say you're in an elevator, and in the worst case scenario, the cables break and you start free falling. You're no longer feeling the effects of gravity. It's as if you're weightless. You could start doing magic tricks to the other people in the elevator. Say, hey, look at this pipe, and let go of the pipe and it would just float there because it's falling, you're falling all at the same rate. But if you're already standing on the floor, you'd stay standing on the floor. However, anyone who was walking, at the moment they were walking, they were pressing their feet down on the ground and then lifting their feet up. And at that moment, if the gravity was turned off, they would have launched themselves up. And without gravity to slow their ascent, they would keep rising in that way. So the people who were stationary and started to float up, not so much. Anyone who was walking would indeed start to flow up. I'm not quite sure how the artificial gravity is being generated in the space station.
I was about to, okay, so if I had to take a guess, I don't know anything about physics. Like, I have a very, very cursory understanding of things. What I have seen or heard talked about was in order to create artificial gravity, you have like a cylindrical thing, almost like a donut. It's spinning around, and that momentum is what's giving you artificial gravity. And so it's sort of holding you against the floor for all intents and purposes at a rate that simulates Earth gravity. If that thing that is spinning around were to suddenly stop, I feel like you go flying, perhaps. I don't know. I don't really know how that works. I'm sure there's physics people watching this can explain it to me better. But like, I loved that he brought up that if you were in an environment where you could create artificial gravity or just stop it at will, that wherever you're at, you'd basically stay. That's something I didn't even think about, you know?
It's good for me to know, should someone mess with the gravity in a room, I will have 10 toes down. I'm not floating.
I mean, unless you were able to like temporarily reverse the gravity and then shut it off, so that you're giving some kind of momentum to the individuals. So like the roof, it becomes where gravity is coming from for a moment. So you get people off the ground and then you shut it off. So now people are moving.
Oh, and they continue moving.
Yeah, exactly.
Swim right out of there.
Yeah, exactly.
And the whole notion of artificial gravity that can be turned on and off at will in generalized locations in the space station, that's a bit too far. Talking raccoons, that part's okay.
Yeah.
3.
My undying fidelity.
So Thanos has just acquired the Space Infinity Stone. And as soon as he has this, he's able to stop Loki's dagger thrust in midair.
Undying. You should choose your words more carefully.
Well, there's actually some real physics behind this. Back in the beginning of the 20th century, Emmy Noether was able to show a deep, intimate connection between space and momentum. Controlling the space stone not only allows you to teleport, but apparently also gives you command over momentum. Loki's dagger thrust is arrested, and all of the momentum is stopped. If you look closely around Loki's arm, you see a little blue glow that's coming from the space stone that's arresting the momentum of his thrust. It's worth noting that in Captain America: The First Avenger, the space stone, which was embedded in the Tesseract at the time, is the only Infinity Stone that was actually weaponized by Hydra and used to create force beams, thereby showing that there is indeed a connection between space and momentum.
Oh.
I didn't really get that, did you? It kind of flew over my head a little bit. I suppose if you have access to this magical thing called the Space Stone, I suppose you can just control the
movement.
He mentioned this lady. I'm like, what did the lady have to do with
yeah,
anything?
Yeah. Who is she?
Was she like a Thanos before Thanos?
Yeah. Did she create the space stone?
I felt like a red herring. It took me in a different direction. I wasn't understanding.
Yeah, and then never to be brought up again.
Yeah.
Okay. Oh, such a good movie.
The first Iron Man movie, 2008, the one that started the whole Marvel universe. I love it. Tony Stark, the superhero as engineer, and the engineer as superhero. When he built his first suit in a cave out of scraps, it was made of iron and was very heavy, about 150 pounds, just counting the iron, not counting the weaponry. Then he developed the Mark II, which was titanium. Titanium is lighter than iron and strong. And then in order to combat the icing problem, he used a gold titanium alloy.
Oh, interesting.
Connect to the Cisco, have it reconfigure the shell metals, use the gold titanium alloy from the Seraphim tactical satellite. That should ensure fuselage integrity while maintaining power to weight ratio. Got it?
Now, there are gold titanium alloys. They tend to be very brittle. They're used in dental applications more than anything else. So unless he's fighting, crime boss gingivitis, I don't think that he's really would want to use a gold titanium alloy. So much of the technology, except for the arc reactor, are things that we actually have right now. We have exoskeletons, we have plating, we even have jet boots. The one thing we don't have is a power supply. He has an arc reactor that's about the size of a hockey puck and puts out the power of 3 nuclear power plants. If we knew how to do that, we wouldn't need superheroes.
It'd be so radioactive as well, wouldn't it?
Yeah. It's cancer upon the first use.
Yeah, exactly. All those goofy scenes where he's just like being tossed around by his rocket thrusters and whatnot. It takes a completely different tone when you think about the radiation it's outputting.
It's like Wolverine.
Yeah. But I mean, maybe perhaps it's just like he's figured out a way to contain it,
It's Tony Stark.
Yeah.
Because otherwise you'd have an Iron Man suit, but you'd have to drag a long extension cord behind you in order to have enough power for the suit. One thing that's realistic.
I would actually love to see a superhero that's like that, because like The Boys, right? It's like, okay, what if superheroes were real, right? But what if there was a world where you get the next closest thing? If Iron Man was real, how would you supply him with the power that he needs? Like they've shown us like lightsabers. Like, okay, here's a real lightsaber, real, right? But it has this like extension cord to power it. It's like, okay, so like what if you had stuff like this? Like you had superheroes that are just super in terms of them crafting this stuff, and then like Jedi Knights, but like it's not like a cool George Lucas lightsaber.
Yeah.
It's like a steampunk thing,
They're like, you have 50 feet to fight.
Yeah, exactly.
You leave this zone, you're dead.
Yeah, I mean, it could even be integrated into the fight where you get them to trip on your extension cord or their own.
Yes.
That could be up the ante a little bit.
In this is that we never see him when he engages his boots or shoots a repulsor ray. We never see him press a button or give a voice command. He thinks it, and it happens. That's because he has a cybernetic helmet that picks up his thought waves and sends the information to the suit. This is real.
Whoa.
Scientists and engineers at the University of Minnesota and at other universities and institutions around the world are developing cybernetic helmets that pick up the very weak radio waves that are generated when we think, amplifying them, sending them via Bluetooth to another device. They're trying to develop prosthetics and treat paralysis, but if you had asked me as a kid when I was reading Iron Man comics, which part in the 21st century would be the closest to reality, the last thing I would have said was the cybernetic helmet.
That is super cool, and I have seen videos on that, and it kind of like, it blows my mind a little bit. I've seen some videos, I think, about guys who are amputees and whatnot, and they're given a new arm, and it's functioning off of like their brain waves or whatever, and like it's like they have a hand again. It's crazy. Oh wow, 9 out of 10.
Cool.
Why don't you pick on someone your own size?
This has to be a 0.
Yeah.
Because they're just jumping up and down on the board with the same
Ant-Man
weight.
Shrinking down to the size of an ant, even much smaller. When Ant-Man shrinks, he's also able to control his mass. And he shrinks at constant density, so he's very lightweight. When he rides on an ant, for example, he doesn't smush the ant.
That doesn't make any sense to me, though, because he's got the strength of a human. I don't get... It's a comic book thing, so I'm overthinking it.
But when he wants to punch Yellow Jacket, he's able to increase his mass, so there's more force, more momentum behind his punch. How does he do it? In the comics and in the movie, via Pym particles that were discovered by Hank Pym. If they had just given a little bit of lip service to how one changes the size of atoms. They say that they're changing the spacing between the atoms or the space in the atoms. No. The size of an atom is determined via quantum mechanics to be the ratio of several fundamental constants: charge of an electron, mass of an electron, Planck's constant. If, via the Pym field, to adjust, say, the magnitude of Planck's constant, make it 10 times smaller, then the atoms would become 100 times smaller, and the size of an object would shrink uniformly. If you make it 10 times bigger, the size of the atoms would be 100 times bigger, you could become Giant Man.
4 out of 10? I don't even understand how you got to 4.
Wow.
What the hell? What? Okay. What?
I guess because he's saying that you can change the size of an atom, but not the space between them.
When he was explaining, I don't know what I'm talking about. I'm gonna sound like such a goof. When he was talking about the logic inside Ant-Man, that actually kind of made sense to me of shrinking this, because like, I guess to me, the reason why I got confused about Ant-Man in general is because I thought you were essentially just making an object or a person more dense. So you were shrinking him down, but he was just more dense. It was like, he was occupying less space, but it was still the same mass ultimately. I don't know how to make sense of what I'm talking about. Like, okay, a neutron star is smaller than Earth, but a teaspoon of it is like 2 tons because it's so dense.
Yeah.
So if you shrink the space between the atoms, you have the same mass, but it's just occupying smaller space. But like to shrink the weight is what confused me. I'm like, how do you shrink something's weight at will? But like, you got Iron Man who's got the nanomachines, and the Spider-Man with the nanomachines that just at will like form these different things out of nothing. I'm like, all right, well, it doesn't even make sense to question any of this at a certain point.
Yeah, that must be the part that you can't prove, like how the suit itself can weigh less.
Yeah. I mean, in Iron Man 2, it was the most egregious to me. He's just got it walking around like it was almost like a swag bag from E3 or from Comic-Con. It was so lightweight, and he just tossed it onto the ground, and then it formed his outfit. I'm like, I don't care how much gold particle or whatever the thing you talked about a moment ago is in there. Like, that would be heavy, wouldn't it? It's super dense.
It's kind of like Hermione's bag of that like stretches, and she can carry all of these different things at once.
Or Mary Poppins.
Yeah.
Spider-Man! Oh my God, this is it! Tell everyone to hang on!
Oh yeah, I see that looking class a lot. So here, Peter Parker Spider-Man needs to stop a runaway elevated train. He shoots out multiple web lines. They stretch a great deal, but they don't break, and he's able to stop the train.
Tell me this makes sense. Please tell me this makes sense.
How strong does the webbing have to be?
Tell me it makes sense,
We can
please.
look up the mass of a train.
Extrapolate the strength of a spider web, please, and tell me that this is possible.
We can estimate its initial velocity by seeing how long it takes to pass city blocks. We can look at the distance over which the webbing stretches. We can estimate its diameter. We can count the number of web lines. And we come up with a tensile strength for the webbing that has to be about 1,000 megapascals, which is equivalent to 145,000 pounds per square inch. But real spider silk has a tensile strength of 1,200 megapascals. If Spider-Man's webbing is anywhere as strong as real spider silk, then this indeed could happen. Yes. He's shooting it out of his wrists, which is not what a real spider would do, but we'll just leave that aside.
Yes!
Wow.
Oh, come on, why can't that be a 10 out of 10? Come on.
Wow.
I just knew, because like, spider web is so strong. I mean, for its size, right? And you extrapolate from that something that is human size, I'm like, that's going to be insanely strong.
Yes.
You know?
I think it had to do with Tobey Maguire's face. Like, the more constipated you look, the stronger the webs are.
Right. Yeah. But I mean, the part that doesn't make a heck of a lot of sense, I suppose, is, well, his is bio, but if it's just like this tiny little cartridge.
Yeah.
That you just,
yeah.
I'm like, come on.
No.
Doctor Strange is a deviation from all the other Marvel movies insofar as everything else in the Marvel Cinematic Universe up till then had some sort of hand-wavy super science type explanation. But here they're going for just full-on magic.
This doesn't make any sense.
Not everything does. Not everything has to.
The notion that there are multiple dimensions is an idea that has been taken seriously by at least some physicists.
What if I told you the reality you know is one of many?
Quantum mechanics is the branch of physics that describes the properties of atoms and how they interact with light. One aspect of quantum mechanics that many scientists find troubling is that it only deals with probabilities. So you can calculate the probability of a measurement giving the electron at a certain location in space and time, but not exactly where that electron will be. One alternative explanation is that there are actually an infinite number of parallel universes. You find the electron in one location, but in other universes, it might be at some different location. So presumably, maybe Doctor Strange is visiting some of these parallel Earths that have undergone significant quantum deviations from our own. As far as the science there, even if they're in a parallel Earth, the fact that their antagonists are able to affect the orientation of gravity locally, I'm sorry, that's just magic. But he's the master of the mystic arts, so I'll give him a break.
Yeah, I'd give that a -1, actually.
Yeah.
But hey, it was fun. I mean, Doctor Strange is my favorite, hands down. Even that little preview of the visuals from the film, I'm like, it's one of the best just eye-gasms ever, you know?
Yeah, looks-wise.
Yeah.
Come here to put an end to Loki's schemes.
Then prove it. Put that hammer down.
Yeah, no. Bad call. He loves his hammer.
You want me to put the hammer down?
Thor puts the hammer down on Captain America's shield. In the movies, the shield is made of pure vibranium, where in the comics, it's an alloy of steel and vibranium. That's actually more realistic. You want steel to provide strength and rigidity, so that when Captain America throws his mighty shield, it will ricochet. But you want the vibranium because it absorbs all vibrations, making it the perfect shock absorber, as it's absorbing Thor's hammer blow in this scene.
Wait, is vibranium a real thing? I thought that was made up.
Wait, I thought it was a play on, is that real?
You thought it was a play on titanium?
Or uranium.
Yeah, no, titanium would be probably close.
Completely vibration absorbent.
Energy can't be destroyed, it can only be converted to another form. The energy of the hammer strike is converted into sound waves in the hammer. And if the vibranium absorbs it, what form does it take? What we see from the clip. It's converted into blue light, ultraviolet light. This enormous flash of light that's given off is showing that the vibranium is actually a perfect sonoluminescent material. Sono meaning sound, luminescent meaning light. You send sound waves in and you get light out. This is a real phenomenon in physics. The only real difference is that vibranium unfortunately doesn't exist.
Okay, there we go.
Oh.
I gotta come up with that first.
It's quantum entanglement between the quantum states of Posner molecules in your brains.
Do you guys just put the word quantum in front of everything?
This is a classic example of quantum mumbo jumbo. There are some real words and real concepts that we use there, but they're used in a context or in connection with other phrases that I just cannot follow. But quantum entanglement is a real thing.
If a physics expert can't follow your mumbo jumbo, there's definitely an issue.
Yeah. If he can't make sense of it, we are screwed.
Yeah.
If you bring two objects so close together that their quantum wave functions overlap, then they can only be described as a single two-object quantum wave function. And if I bring them very far apart and I don't disentangle them, then they remain connected. So something that's done on this end shows up in the other end, even though they could be on opposite ends of the Earth or opposite ends of the solar system, they would still be communicating to each other because they're still described by one single wave function. Scientists are using this property of entangled quantum states to try to see if they can develop superior computers. They're trying to make the context for a character in the movie Ghost, who is quantum mechanically tunneling through solid objects. A real phenomena, but the way they're doing it just doesn't really make sense. A little bit too much quantum woo. So I say less
quantum
woo, more quantum.
Woo.
I'm going to make it.
Keep going.
That's dope.
Yeah.
I haven't watched
So
this
here
in a
we
long
see the Black Panther and his sister, scientific genius Shuri. She's using a holographically generated car in Wakanda to steer a car the Black Panther has commandeered in South Korea.
Which side of the road is it?
For God's sake, just try.
I'm willing to bet that there is a lot of accuracy in here, or at least is going to give it like a lot of a higher rating, because the idea of being able to control something remotely is already something we do anyway.
Yeah.
What makes Wakanda special is that it's near inexhaustible supply of vibranium, an extraterrestrial mineral that has the ability to absorb all vibrations. The hard light hologram always used to bother me. Holograms are interference patterns created with light. The hologram itself is not an actual object, it is an image. But I thought about it some more. Using sound, you can create regions that have a pressure and exert a force as if they were a solid object.
Oh, wow.
And presumably, if you overlay that with a optical hologram,
wow,
you would have something that feels solid, but is generated via
Pause
light.
it really quick.
You okay?
Swallowed that wrong. Oh, sorry.
Corona.
Overlay that with a optical hologram, you would have something that feels solid, but is generated via light. Presumably, using their command of Vibranium, Shuri is able to do this and overlay it with an optical hologram, which has no solidity, but still produces a visual image for her to interact with. I don't know if I could create a interference sound pattern overlaid with a hologram to create a hard light object, but Shuri, someone can.
That was bad, but good.
Oh, okay, 5 out of 10. All right, I'll take that.
Yeah.
I just figured, you know, because like you have these things that you see all the time now where, you know, there's this notion of like a keyboard that's just basically your table. Like
yeah.
you can see a light, something is projected onto the table and it's detecting your fingers touching the keys and whatnot. I've heard that it's actually uncomfortable to type on that because like you do that because there's no give. It actually hurts your fingers after a while. Because there's that, and there's like the sensor from like the Xbox Kinect, right, where you're just moving around. It's just detecting your motion. I'm like, surely this is like, Shuri, this is something that's totally doable.
Too.
Yeah, I figure that's totally possible, but anyway.
Surprising absolutely no one, here we see Carol Danvers, Captain Marvel, showing up in Avengers Endgame, obviously responding to the SOS call sent out by Nick Fury at the end of Avengers Infinity War. We last saw her in the mid-1990s at the end of her own movie, Captain Marvel, where she took off into outer space to try to find the Skrulls' homeworld. She comes back to Earth 24, 25 years later, doesn't appear to be any older. Einstein's special theory of relativity says that all observers, whether stationary or moving, have to agree on the value of the speed of light. For that to be the case, they will disagree about distances and disagree about times. There's an effect called time dilation that if someone is moving very close to the speed of light, to a stationary observer, time will appear to have been moving slower. Say she spends 6 months traveling close to, but not at the speed of light, then 6 months traveling at this velocity would correspond to 24 years passing on Earth.
Oh, wow, yeah.
We don't know what's going to happen in Captain Marvel 2, but if any of it involves traveling near the speed of light, then the time dilation effect could easily account for the fact that she doesn't appear to have aged significantly from the last movie.
Huh. Wow.
Oh, whoa.
This has been Jim Kikalius, your friendly neighborhood physics professor, and in the words of the legendary Stan Lee, face front, true believer.
What's the matter with you kids? You never seen a spaceship before?
Please, bring him over here and hold on for safekeeping.
That is hilarious.
I've been waiting to watch that one for a while, and I thoroughly enjoyed it. I thought that was actually quite informative. Are you okay?
Yeah. I had a slight swallowing the coffee wrong. After all my years on Earth, I can't drink water, right? That's the science. That was really fascinating. I love physics, don't know much about it, but every time I see a video, I'm like, whoa, I want to learn more. And then I go to read a physics book, and I'm like,
It's one of those things, it's almost like a religion in a way, where you're, because it's abstract to me, because I don't understand the specific mechanics of it. Like, I tried to, in high school, I tried to like wrap my head around it, and even the terminology can throw me off. Like, he's talking about kinetic energy versus potential energy and stuff like that. Like, those concepts right there, I tried to understand the equations around it in high school, and I'm like, I can't even figure out how to, I get it conceptually, but I can't, like, relate it, I can't regurgitate it. I don't know how to, like, convey my understanding of it. My understanding is so cursory. Even saying that it's cursory is being nice to me. I do love all that is involved with it from like the outsider perspective of just like looking at magic for all intents and purposes. And his breakdown of these Marvel scenes is, you know, you take it with a grain of salt. It's one physics professor or one physics expert's opinion on Marvel films. And I think that he's looking at a cartoon and going, well, if you want if you want to examine this with any sort of authenticity, then sure, here's how you do it. And he's sort of just indulging us, right? You know, I've heard Michio Kaku talk about Marvel stuff, and he talked about how some of the concepts involved in Marvel actually do relate to some of the things in actual science. But again, it's just like, take it with a grain of salt, you know? It's just whatever. It's all for fun. None of it actually makes any real world sense. You know, like all of it fused together is just magic, and it's just for fun, you know? But
some of it.
Yeah.
Some of it is based in some reality.
But like, even people pick it apart real quick, like Multiverse of Madness, for instance, right? It's, okay, so you have access to the unlimited multiverse, and you're telling me you can't find a universe where Wanda is dead and her kids are alive that she can go and inhabit?
Yeah.
You know, it just, come on.
You can't think too much.
Yeah. And not only those two laws, but or those two situations, but also additionally, they have all the medicine in the world post Wanda dying, because one of Wanda's things was, I have to take America Chavez's power so that I can go to any universe where they've got the medicine that they need from my kid.
If they're sick, yeah.
Yeah, if they're sick, which itself is a little bit wonky. I mean, okay, that's a different universe with potentially different rules. How's that medicine going to apply? But whatever, let's just not think about it too much, right?
Yeah, but it's fascinating because art imitates life, right? So when you're watching some of these things, especially Iron Man, I'm like, can we get these suits?
Yeah.
Like, can we build these suits for people, especially if they're protecting? But then I think that'd be scary because we already have like robo dog cops that I don't want around.
Yeah. Oh, I was thinking actually about like military people who control drones and whatnot. It's just, you're talking about people who are behind a computer screen and whatnot. And to me, what Shuri was doing was just like the next level. I think that the light show and whatever, that creates the holographic imitation of the car. I mean, I think it's a little bit extra and unnecessary. It just looks cool for movies. Yeah. And I'm fine with that. It's just a fancy thing for movies. But like, I think the mechanics of it actually do make sense. So
yes, to be able to actually operate something from a remote location. Yeah.
Exactly.
I believe.
My favorite part of this whole video though was the Spider-Man breakdown, because I was like, oh, that's awesome. Like, if we could actually figure that out.
That one was a 9 out of 10.
Yeah. Yeah. Well, it was actually 8 out of 10, but still close enough. I'll take it, you know?
We like it though.
Yeah. You guys, thanks so much for hanging out. Hopefully you enjoyed this. Do subscribe, bell icon, all notifications, vote this up. I'm Jabby Kuwait. This is
Steph Sabra.
Peace out.